Okay, now, so I think Vijay attended this demo. So most of this demo will be familiar for Vijay. But for Subbu, I'll repeat this. Vijay, you are there on the demo, right? Last time?
Yeah, I was there.
Yeah. Okay. So let me tell the same thing today. Most of the time. But for since Vijay is also present, we'll try to wrap this demo part quickly and then start some basics on data science so that Vijay will also get benefited. Okay, let me start the demo now. So what is data science? So most of the times, it always helps to understand what and why. So most of your classes will be like this. I'll be writing the notes here so that you'll be seeing what I am writing, and you'll be knowing everything, whatever. I mean, there is no slide actually. There is no slides in this entire course. Everything I'll be writing in front of you. So that way it helps actually. Going forward, any mathematical concepts or anything related to data science, you'll be seeing that I'm writing on the board. Okay, so now what is data science? So most of the times, it helps to understand what we are doing and why we are doing any of the things that we are doing and why we should be doing this way. So that's why I always start with this kind of discussion. So first of all, what is data science? So most of the times, there is a lot of business decisions that are going inside. So for example, should I take this product product line forward in this direction or not, or should I invest in this area of my business or this area of the business? So all these business decisions go hand in hand with data science. Now what is data science is, every time you are making any decision on business, your data science is going to help in giving more ideas or more intuitions about what to go. So for example, let's say there is a business decision on, should I open a new service center for a car. So there is a service center. So let's say there are 100 service centers in the city, and I want to add a new service center to a location called, let's say X, or let's give a name, Times Square. So in Times Square, can I open a new service center? Of course, Times Square is not very. I mean, getting an office space in Times Square is not very easy. So it's going to be costly. So opening a new service center in Times Square is going to be very costly, and to decide this, what is my basis? So should I open the Times Square new service center or should I not? So most of the times what happens is you go by your gut. Most of the times you go by gut or you go by an experience. So past experience. When I say experience, it is from the past. So how do you go by experience? Most of the times, there is a lot of other car manufacturers who already opened some service center in Times Square, and based on those manufacturers, each manufacturer might get some profit, or they may not get a profit at all. So the data will be like this: manufacturer, service center, and what is the cost of service, open date, when is this open, When did this service center get opened? So let's say this is the data that we collected. Let's say there is a manufacturer X and service center is in Times Square, and I need profit or loss, right? Obviously. So did he get a profit or did he get loss? So let's say cost of each car servicing is, let's say, $40 at minimum, and open date, let's say May 2018, 2017, and let's say he got a profit. I'm keeping a P for profit. I'm sorry. Now there is a manufacturer Y, same Times Square. Let's say this guy is giving service for $35, and this is opened on April 2017, and there is a loss, let's say. So you get some data like this, and you need to analyze based on these manufacturers and this service cost and open date and all this data, whatever I have provided here. You need to identify whether the service center is good for you or not. I mean, are you going to open the new service center or not? So these decisions you can either take by gut, which means okay, I can open a new service center in Times Square, but I don't know what is the ground reality there. But I go by gut. I go by pure gut. But most of the times, gut is going to play a trick. Sometimes your gut may be good, but you may still get a loss. So in decisions like this, your business is not going to spare you if you go by gut. Maybe you're laid off in the next quarter once your service center is making loss. So most of the times what you do, instead of taking a decision by gut, maybe you take by experience. Again, taking by experience is also a difficult thing because you may or may not get a domain expertise for your company. Domain expertise is a relatively it's relatively same as gut actually. Only thing is he has the person who has experience might have a better gut, not more than that. So are you clear, Vijay and Subbu, until here?
Yeah.
Yes, sir.
So most of the times, you go by either a gut or you go by experience. But experience is nothing but it is more like an experienced gut. It's nothing more than that. Which means, he has a better gut than the person who doesn't have experience. Whether it is a domain expertise or technical expertise, we don't care at this point. But most of the times, experience and gut, all these are one and the same. Now, instead of doing all these things in this way, there is a new area. In fact, it's not very new, but we can call it new for the time being. The area is called data science. The terminology is very new actually, but it was called statistical learning earlier. So, or decision science. Decision science. All are one and the same. So this is what we'll be doing in the next couple of months. So what we'll be doing is we'll be taking a data set like this, whatever I wrote here, and then process using some of the statistical techniques, and then find out business decisions out of it. Try to extract some of the business decisions that you're going to take in future and then incorporate it in your business. Now, what is the advantage with all this process? The advantage is you have an automated way of taking decisions. Till now, your computers are only taking instructions. So there is something called instruction based learning. Or instruction based programming, let's say. Now, what is this? Your computer actually only takes a set of instructions. That's what is a program. Whether it is a Python or Java or Scala or whatever, Groovy or whatever, all the computer takes is instructions. So what does it mean by instruction? So let's say there is a value 40 and there is a value 30 and you want to get it added. What you do? You assign this to X and you assign this to Y and then you say X plus Y. So this is what we are coding till now in all the programming languages in all the computers till now. So what we are doing is we are giving what to do to the computer so that computer will compute it and give the result. So till now what we are doing is we are making the computer dumb. We are saying what to do, how to do, everything we are programming it within the computer, and the computer just executes. Now what we are learning is we are doing experience based programming. What does it mean? It means that let the computer learn on its own, let it gain the experience, and then it may do some more magic than what you expected earlier. So this is what we are going to do in the next few months. What we are going to teach the computers or even yourself is learning how to gain this experience. So what does it mean by experience? So for example, let's say you're given photographs of all different animals and you're asked to identify which animal is what. So how do you do? So generally in all the curriculums in the schools, you'll be starting with a bunch of photographs. I mean, in your school days, maybe primary schools. So you're given a lot of photographs. Each of them represents some animal, and you are told what each animal is. Now, in future, even if you see a different variation of the same animal, let's say the animal is, let's say, tiger. So there may be 100 different variants of tigers. There is a Bengal tiger, there is a cheetah, there is a lot of different varieties of tigers. But you're shown only one kind of tiger, but you are still identifying even the 100 varieties, even though you don't know what is the exact category that it belongs to, but you can say that it is tiger. So but the computer doesn't know this kind of automated way of decategorizing things, I mean categorizing things. So that's what we're going to teach the computer, how to identify each animal. So for example, let me show you some of the tiger pictures. You'll get what I'm saying. Let's say I told the computer this is a tiger. Will it ever identify this kind? This is more, I mean, I can identify, but the problem with the computer is the angle in which this is photographed versus the angle in which this is photographed is completely different. And the texture of the skin of tiger, it's completely different. It's kind of an orange kind of thing here, and it is more like a white skinned tiger here. So each tiger, even though you tell that computer that this is the tiger, the computer may not be able to identify. So these are the things that we are going to address, not on the pictorial level, but on the textual level. So identifying on a photograph is a different kind of data science. It is called deep data science, which we are not going to learn. But to get you into the intuition, I am just showing this kind of a picture. Are we clear so far?
Yes.
Yes, sir.
Yeah. So now, what are we going to achieve in data science? What can we do in data science? So what are the kind of things that we're going to do or deliver in data science? So there are majorly and primarily there are only three kinds of things that you can do in data science. Let me write in bullets. One, which category does it fall into? So the tiger example that I gave you is the same question that I have, right? I have different kinds of animals, and which category that this current animal is falling into. And this is called in data science terminology, this is called classification. Okay, so classification means that you have different kinds of animals. Maybe one is a buffalo, another is a tiger. There are 100 different categories for animals. And which animal does it fall into? I mean, which animal categorization does it fall into? Is it a tiger, or is it a lion, or is it a buffalo, or what is it? Or is it a rabbit? All these things fall into classification. You're classifying things. There is a second variety of data science that we're going to look at, and this is called this is for how much will it be in future. The question is, how much will it be in future? What does it mean? In a lot of companies, you may want to see what is the future profit. So today my profit is let's say $10 million. What is my profit next year? How will my profit gets impacted in the next 2 years? So all these kind of questions will come into how much will it be in future. It is an exact number. I'm talking about a number, how much. So when you are predicting some numbers, this is called regression. So many times, even for, let's say, your electricity bill. So let's say yearly I am paying $1 million. As a company, I am paying $1 million to the electricity department due to my electricity costs. How much will it increase in the next 5 years? So if I want to do all these kind of predictions, this is called regression. And the third category The question is here, what is it similar to? So for example, here, let's say you have let's say you have a lot of pictures of let's say some liver, your intestine or liver or whatever. So let's say there is if the liver is impacted with cancer, the liver looks like something else, and if it is not impacted by cancer, it is looking like something else. Let's say these are the two categories you want to, but you don't know what is what. When it will look like when it is a cancer, when it is having cancer, when it how it will be looking like, you don't know those things. You want to just separate these photographs into two parts, only that you want to do. So in that case, you don't know where when the liver is having cancer, when it is not having cancer, all those things you don't know. So in those cases, what you want to do, you want to group the things together so that you can do further analysis. So in this kind of situations, what you're going to do is something called clustering. Okay, so these are the three different major algorithms that you are going to look at. For example, classification, you are going to look at multiple different machine learning techniques. Regression, it is a topic by itself. You are going to learn for, let's say, 30 hours or 40 hours roughly. And clustering is a topic within machine learning that you're not going to learn that much, but you're going to learn, let's say, 3-4 hours. And classification is a major topic, and this will be going until, let's say, 30 more hours. And apart from these, there you need to know some basic statistics. This will take another 50 hours or 40 hours actually. So overall, you're looking at some 120-130 hours around all these topics actually. So that's how the course is organized. So any questions on whatever I covered till now?
No, Sandeep, it's clear.
No.
Vijay, are you clear on this?
Yes, no questions.
Okay. So let me show the syllabus. So this is what you are going to do in major part. But for all these things, you need statistics. At least half of the regression needs. 90% of the regression needs statistics. Around let's say 30-40% of classification needs statistics. Clustering doesn't need statistics. So statistics is going to be your backbone for this entire course. So we'll be starting everything on statistics, then we'll go further into other machine learning techniques. That's how the course is organized. Now coming to the syllabus. So like I said, it is around 120 hours of course. Most of the times, at least in the last time, it went up to 140-150 hours. So I'll be teaching more but not less. That's how I should mention this. So even though I mention it as 120 plus, it might go until 140. So bear with me if I am going to teach more, but I'm not going to teach less. That is for sure. So these are the statistics concepts. So statistics is divided into descriptive and inferential statistics. First, we'll be looking at descriptive statistics. Within that itself, I included some Python module where we'll be teaching everything on Python, how to use this in Python and all those things. Actually, earlier I used to teach everything on R. Now I realized R is kind of difficult language to learn. It's very easy for the first 10 days, but if you want to go anything deeper, you cannot go deeper inside in R. It's going to take a lot of time actually if you want to learn R in deep. So that's why I removed the R module and added Python. Now I'm going to teach everything on Python. But initially, some of these descriptive statistics, even in the inferential statistics as well, I'm going to teach some Excel concepts as well. So I'm going to show it most of the things in Excel, then transform your knowledge from Excel into Python programming. So that's how I'm going to do. The reason is Python is most of the times, any language, any higher level language, it's going to hide some of the details. It's not going to show everything. So some of the internal details, if you want to learn, so it's very difficult on Python initially. So that's why I'm going to show everything on Excel, how it is getting calculated, all those things. Then once you are clear on how the calculation is happening, then I can transfer your entire knowledge onto Python. So that's how I'm thinking about this course. That's how I did last time as well, and even every time. So that's how I'm going to do even this time. And it's going, don't worry about Python and R and Excel and all those things. You'll know that Excel and Python and R, all these things are like not even 10% of what you are going to learn in this course. So you're going to learn a lot more than what Python offers. Okay. So like I said, there is a descriptive statistics module and inferential statistics module. So both the modules together will make up the statistics part. And this will be the background knowledge that you're going to, that you need for all the regression and classification concepts and clustering. So once this is done, we'll enter regression module, where again this is around 30 hours, but it will be, sometimes it will be more depending on how you're taking the inputs, whatever I give. So in regression, most of the times, like I said, you'll be only talking about numeric output, right? That's what I mentioned, right? What is regression? Regression is how much it will be in future. So how much means it is a numeric output. So most of the times in regression, you'll be only talking about how to predict a numeric output. But at the end of the regression, you'll start knowing that regression can also be applied for some categories. You can do categorization using regression. I mean, it's a common technique for using category classification. So at the end of this module, you'll realize that now you can start using now you can start using the regression concepts in classification as well. So that's how the course is organized. Once the regression is done, you'll get to know that regression and classification are closely related. Sorry, these two are closely related, but you'll not know until the end of this regression topic. These two are closely related. Okay, so that's how you enter into machine learning. So most of the machine learning, even though I said machine learning, this is more like a classification and clustering. Those are the two things that you will be learning here. So within machine learning, there are multiple topics. I'm not going to explain each of them now. You'll get to know in future anyway. So at the end of the course, mostly you'll be learning clustering, which is a very small technique actually. Once you learn all the basics, the clustering concept will be very, very simple actually. So that is how the course is organized. So I'll be teaching for 1.5 hours every day, and the classes starts from 6:30 a.m. in IST, which is 8 p.m. EST, I believe. 8 p.m. EST to 9:30 p.m. EST will be your time in US. For whoever is attending from India, it will be from 6:30 a.m. to 8 p.m. Okay, and the classes will be 5 days a week. So it is from Sunday to Thursday for US, and Monday to Friday for Indian times. Okay, let me write it so that it will be clear. So for US, it is 8 p.m. to 9:30 p.m. I'm writing in EST, and this will be from Sunday to Thursday, 5 days a week. And for India, it is 6:30 a.m. to 8 a.m. IST, and this is from Monday to Friday. I'm writing in different time zones so that it will be helpful. Is that clear?
Yes, Sandeep. Yeah.
So Vijay or Subbu, any questions till now?
Oh, can you email the syllabus? Is that possible?
Yeah. So for that, I think you can you post your email ID to this chat group? You have a chat, right?
Yeah, I'll do that. Oh, and your email address, if should we have questions?
Yes, I'm posting it. Okay. So you can save my email address. And I'll write your email address down. Okay, Subbu, you can also post me your email address so that I can send your whatever I have.
Okay. I'm posting.
So I'll post the syllabus to your email addresses. Let me do that after the class so that we don't waste the class time. Okay, so that's all about the demo part. What we are going to do and why we are going to do whatever we are doing. And there is one more thing I just wanted to mention. So out in there in the market, you'll be seeing many catchy terminology like IoT. Data science is one of them. Probably you may not. You may also have heard of big data, right? So each of these are catchy terms in the market today. But I would say, when you put all of these in a stack, you'll get to know where everything stands. So in a way, IoT is a data collection framework. It's more like collecting various devices data. So it comes at the bottom of this entire stack. And then comes, once you collected a lot of data from various devices and all, then comes how to process the data. So there, big data comes into picture. So, big data will utilize, when I write this in this kind of a stack format, what it means is big data is utilizing the underlying IoT to process the data. Whatever IoT has created the data, IoT is nothing but various devices on the network. It's going to post all the device information into some central repository. That could be your big data. That central repository could be big data. Once all the data, a lot of data will come. Once the data comes into big data can process this data very fast. That's the only advantage that big data has. Now at the top of this layer, you get data science. Why would it come here? The reason is big data is always saying about processing the data, but it's not making any decisions by itself, right? So all the data that it is going to process, you can still utilize the infrastructure given by big data, but use data science so that you can make decisions, some intelligent decisions than random and dumb decisions. If you want to utilize the full power of IoT, there is no other alternative other than data science. If you want to learn, if you want to process a lot of data, but still give intelligent decisions, again, there is data science. So whenever there is something around intelligence coming into picture, the intelligence is nothing but data science. So that's how these three are organized. So if you hear a lot of market buzzwords and all, most of the times you might have heard of these three things. But I would say, IoT is nothing but it's a dumb data collector. Big data is also dumb. It's just a data processing framework. It's nothing more than that. It's only when you call something intelligent, there should be some data science applied to that intelligent system. So that's the reason why I kept the stack like this. At the bottom of the stack, you'll have IoT. And the middle of the stack, big data will utilize the IoT to process a lot of information, a lot of data. And then at the top of the stack, you'll have data science. This is how everything is organized. Hope this clears, the market buzzwords, what we're talking about in the market. At least these three are related. There are some unrelated buzzwords which I am not going to talk about. Is that clear, Vijay and Subbu?
Yes.
Yes, Sandeep.
Okay. So we'll go into a little bit of subject today. Now that we have like a half an hour or so, is that okay, or shall we start the classes tomorrow? How do you want?
Anything fine, Sandeep?
Yeah, I'm also okay. Anything.
Okay, so I can start then. Instead of wasting time, I would say we'll start with some basics. By the way, I have not talked about the course fee, right? The course fee is $2,000, and we'll have three demo classes. Actually, there is no demo. In fact, I would not call anything as a demo. Most of these things are the class syllabus itself. So there will be three classes until which you'll have time to pay the fees. And after that, once the fourth class starts, before the fourth class starts, you can pay me the fee. Okay, you can either pay by check or cash. Anything is fine. You can also do a bank transfer if you want.
Okay.
Okay.
Yeah.
So, okay. Now that you got some intuitions about what is data science, how everything is utilized and all. By the way, this entire notes, whatever I write, most of the, I mean, all of these things will be uploaded on OneDrive once you pay the fees. Which means by Thursday you'll be seeing Thursday my time, which means Wednesday night your time in US. You'll be seeing this notes on OneDrive. You'll be getting a link for OneDrive where you can see all the notes, whatever I write. So everything is available to you. Whatever the Python scripts I give, everything will be available to you. And I'll be publishing a Python library that I have wrote in past couple of weeks. So you can install the Python library yourself and work on it. I'll show how to install and all those things. So everything will be all the scripts, all the class notes, everything will be available to you. But I'll not be sharing the video recording unless for specific circumstances I'll be recording. So in case you want to you want to skip for a day or something, in some circumstances I might give you the recording, but most of the cases I'll not give the recording. Is that fine?
Yeah, that's fine.
It serves two purposes. I have a friend who will keep on collecting different video recordings from various professors, the greatest professors from the world, but he'll never watch it. Does it serve any purpose? I don't think so. So most of the time, 120 hours of recordings, even if I give, you will not be able to watch. That is for sure. So anyway, that's about it. So today we'll start some small basics about how data science works and what kind of data sets you will be using and all these things. So let me start with a concept called data sets. It's not a concept, it's some basics actually. Just give me a second. Okay, data sets. So in this entire course, you'll be using a lot of data sets, sometimes simulated data sets for you to understand how that particular concept works, because not everything you can learn from real data sets. Sometimes you need to simulate data sets. Initially, you'll see all the simulated data sets, then slowly you'll migrate to the real data sets. So, but what is this data set and how to interpret the data set? So many times, you'll be seeing the data set in a tabular format. It's nothing but the data set is nothing but a tabular representation of data. So what does it mean by tabular representation? It's nothing but what you see in Excel. In Excel, how do you do? So even in Python, you will be seeing only tabular data set. Those are the kinds of data sets that we'll be working on. There are other kinds of data sets that, things like images, things like audio, video. These kind of data sets are also available, but we are not going to see the multimedia kind of applications now. not in this course. This is called deep data science, and it requires a separate kind of skill. So we're not looking into those kind of applications right now. Okay. So, but what is this tabular data set? So, for example, let's say you have a medical records data. Let's say the data is like this: patient name, let's say he's undergoing some blood blood picture, where I'll be collecting RBC count, which is red blood cell count, and the gender, and the last one is, let's say, has cancer. So most of your data, whatever you'll be looking at, will be like this. So for example, in this case, let's say patient name is, let's say, Subbu, and his RBC count is, let's say, 150,000. Let's say, is this 150,000? Yeah, this is 150,000. And gender is male, and has cancer, let's say it is false or no. And there will be some other person, let's say Robert, and his RBC count is 50,000. And let's say again he's a male, and he doesn't have cancer, or maybe he has cancer. So these kind of records you'll have. So what you're seeing here is the tabular data structure, right? You have a lot of columns and a lot of rows, and each row has information on each of these columns. So that's how your data will be looking like. So what it will be having? It will be having a rows will contain, sorry, one second, contains rows and columns. And in data science terminology, you should not call these as rows and columns. Actually, it should be called as columns should be called as variables. Columns are nothing but variables, and rows are nothing but observations. So most of the times you'll be seeing this kind of data structure only. You'll not see anything else other than this. But sometimes, you might see textual data set, but you have to convert your text. Let's say there is a text like Wikipedia text, let's say. You'll have a lot of text in Wikipedia. Maybe Manhattan Project, I don't know what it is, but I think this is a nuclear weapon project. Okay. So let's say this is the textual data you're given. You have to convert this textual data into this kind of a tabular format. Now, how do you do that? Probably there are many techniques we'll look into when we're talking about naive Bayes algorithm and Bayes law. The idea is you can count the words. Maybe the word Manhattan may be appearing in this entire text for three times. Let me add one more sheet. Manhattan. Let's say this came in for 10 times. Let's say there is a term called bombs here. Bombs. Let's say this appeared for 3 times. So you just count this data and then again tabulate. This is one of the techniques that generally people will use even in NLP and other applications, where you just go through the entire text, count the number of occurrences of the text, and tabulate. This is one of the way. So to convert some textual data into tabular format. Okay, ultimately you are going to process only tabular format. Whether you are getting text or directly tabular format, in any case you have to only work with tabular format. So convert your textual data into tabular format. We are going to learn this kind of techniques. Okay, so that's how your data will look like. Any questions on how the data will look like? So generally we'll call, yeah, someone is opening mic. Any question?
No.
Okay. So we are calling the rows as observations. The reason is, this entire field of statistics started with some kind of a science project. In many of the science projects, whenever you do an experiment, you will collect observations, right? Observations are your primary interface for your entire experiment. So that is the reason why we call it as observation. You do many experiments, scientific experiments. You collect observations. Each observation will consist of some variables and their corresponding values. So that's how the name observation came into picture. So that is about the data set, how the data set looks like and everything. Any questions till now? And one more small topic and I'll just close the session for today. We'll just talk about one more small topic. In fact, it's going to be big in future. So you have observations and you have variables, right? Most of the times in data science, you are not going to talk much about observations. You're going to talk more on variables. Because the reason is variables, when you see these variables, RBC count, let's say this entire column, this is going to have some set of data that it is going to represent the this RBC count is going to describe your entire sample, whatever sample you have. Okay, and this entire gender, how many males attended this collection process, how many females attended. These kind of statistics you can gain only through each single variable. Are you clear? So for example, if I want to ask you a question, how many males are going to get cancer? What is the percentage of males having cancer? So for that, you need to analyze this based on this column, not on the rows. Observations are only going to describe each element. But if you want to talk about the entire set of data that you got, you are going to talk only on the variable side, the column side. So that's why analyzing the variables will give you the entire picture of data science. So we are not going to talk anything on the observation side. It's not, I mean, sometimes we may, but it's only very little. Most of our discussion will revolve around the columns. You'll get to know in future why and what and all those things. But you remember this thing that observations are not very useful. I mean, analyzing the observation is not very useful. Having observation is required anyway. But most of our data science analysis will revolve around variables. So that's why we are going to talk now about types of variables. Or let me write it here itself. Maybe that is better. What is this? Types of variables. Okay. So in this data set, whatever I gave you just now, which is a kind of a simulated one, I gave you various variables. Each variable is of different type actually. You'll notice that patient name is a different type of variable compared to RBC count. RBC count is completely numeric. Okay. RBC count is completely numeric and it doesn't have any textual kind of data. You can count, you can add, you can subtract, you can do all kinds of mathematical operations on this RBC count. But you cannot add Subbu and Robert, for example. So these two are two different variables. And for example, has cancer, it has only two values, but patient name, it can have 100 different values. You don't know what value it can take. But has cancer, I'm sure that the third observation, which I did not write, the value of has cancer, I'm sure that it will be either yes or it will be either no. It won't be anything other than yes or no. But patient name, on the other hand, cannot be either Subbu or Robert. It may be something else. Or it may be Subbu also. I don't know. There may be another Subbu other than what I already wrote. The value that the new observation will take will be differing compared to what I already have. It won't be Subbu or Robert. It may be, let's say, my name, Sandeep. Okay. So the values, the set of values that patient name will take is infinite. But the set of values that has cancer takes is only two, yes or no. So each variable has different properties, right? Now you can get the intuition that each variable is having a different property. So those are the types of variables I am talking about. So there are only two types of variables at a higher level. One is categorical and another is continuous. I'll talk about how to identify which variable is what. So all you have is categorical variables and continuous variables. Now categorical variables most of the times, has textual data like this or fixed set of values which is not numeric. You cannot do any operations on this kind of data. Yes and no, I cannot add. I cannot subtract yes from no, let's say. But continuous data, on the other hand, will have some numeric value and you can do some arithmetic or operation on them. I can add, let's say 50,000, let's say 50,000, for 50,000, I can add, let's say 10. I can always do that. Okay, 50,000, 10. I can always subtract from this, I can subtract, let's say 100,000, 10,000, let's say. I can do all kinds of mathematical operations on these variables. So to identify categorical or continuous, the best way is on categorical, arithmetic operations can be performed. On continuous, arithmetic operations can be performed. So this is the very brief idea of how to identify what is continuous, what is categorical. So in these, let me write the variable names. in these variables, just provide me with what type of data it is. Can anyone try? Vidya, can you try?
So patient name is categorical.
Yeah, that's right.
RBC count is continuous.
Continuous. Yeah.
Gender and has cancer also categorical.
This is categorical. What is has cancer?
Categorical.
Yeah, that's right. That's right. That's how you can identify. I mean, there are multiple ways to identify, but this is the easiest way I can mention to you. I mean, this is the best way that you can identify which is categorical, which is continuous. Okay. So, Subbu, any questions?
No, Sandeep, it's clear.
It's clear, right?
Yeah.
So, yeah, so that's how you identify the variables. So, what else we have today? I think we can stop for today. There is more categorization within these two types of variables, but those things we'll discuss tomorrow. Okay. Okay. Well, one important thing let me talk about, which generally people will get confused. Anyone can answer this. Income. Is it a categorical variable or a continuous variable?
Continuous.
Okay, continuous. Now, can I call it as a categorical variable? In some way, can I make it as a categorical variable?
Maybe if we are doing different sets, like income is based on the, if you want to do different sets, like suppose the salary is less than $50,000 or something, and
Yes.
in that case, maybe we can use it as
Yes. So
category.
salary, let's say the yearly salary is 50K. This would be a continuous information, continuous data. But let's say I categorize these things into low, medium, high. I say, let's say income 0 to 60K is low. Income when it is 60K to 90K is medium. Anything greater than 90K is high. Let's say I had a rule like this and I converted it into categorical. Okay. So most of the times, any data that is continuous could be categorical also. Okay. Any data, any variable which is continuous, we can convert it into categorical also in general. But which one to use? Should I use a continuous data and then process the data, or should I use categorical data? So the answer is no one knows. Really, no one knows. It depends on the particular problem set and the processing that you are going to do. But in general, collect your data using continuous information. When you are collecting the data, collect continuous data only. Do not collect categorical data. Why? Any suggestions on it?
Suppose if we have continuous data, then we can convert it into categorical. Like suppose it is 50,000 K, then we can mark that as low.
Then what if you already have what if you collect as a categorical data?
Category. Suppose if we want to observe what is the income for that person, then we'll miss, and
We miss the exact value.
Exact value, and further analysis maybe it is required.
Yes.
Not.
So that's what. Thanks, Subbu. So when the data is continuous, you can always go into categorical. But when you collected the data as categorical, You cannot go back. This is a one-way path. From categorical to continuous to categorical, it is possible. From categorical to continuous, it's not possible. This is a one-way path. You can only go in one direction. The second direction is not possible. So, for example, if someone says, I have a low income, you can deduce to some extent it is less than 60K. But what is the exact value, you can never know once you collected the data as low income. So always try to collect whenever your data, whenever your variable could be either whenever your variable could be either continuous or categorical, always prefer continuous. Do not prefer categorical unless it is mandatory to. For example, gender can never be continuous. It is implicitly categorical. So you cannot collect any continuous data on this. But let's say if it is RBC count, don't say that RBC count is low, medium, high. Say that, give the exact value of the RBC count. Do not convert while collecting the data. Do not convert your variable into categorical when it is possible to collect as continuous. Is that clear?
Yes, Sandeep.
Okay. Vijay, are you also clear?
Yeah, it's clear.
Okay. So that's all for today. Generally, we'll close at 8 a.m. my time, which is 9:30 p.m. for you. Vijay, are you based on EST or which time zone are you?
Yeah, EST.
EST, right?
Yeah.
Okay. So I think it is 9:15 EST now. Is it correct? 9:15 p.m. Okay. Just to clarify, so that I'll be able to do the time conversion easily. Okay. So generally, it will be closing at 9:30 p.m. EST for you, and for Subbu it will be 8 a.m. So today, since it is first class and we did not cover much, but generally it will be the exact time, 8 a.m. Okay.
Okay,
So
Sandeep.
Vijay or Subbu, do you have any other questions on the class or the structure or the format of the class or whatever?
No, nothing as of now.
Mhm.
But I guess whatever information you go in the mm, I guess as we move along, if we have questions, we can just email you anytime, right?
Yes. So if you have too many questions, probably what I can do is I can share you a Excel sheet on OneDrive.
Okay.
You guys can just add your questions,
Okay.
and we can do a questionnaire session one day,
Okay.
one whole day. I mean, one whole class. We can only focus on the questions and clear them. That is one way. Or if you prefer, we can discuss the questions online itself. I mean, whenever you ask the question, I can answer on online itself. That is another way. Whichever way you prefer, that is fine for me.
Okay.
I would prefer instead of disrupting the class and disrupting the flow of the class, we can do a separate session on only the questions, nothing else,
Yeah, that sounds fine too.
right?
Yeah.
But that questionnaire session I can only do out of these class hours. I mean, I said right, we'll be having five days a week, right?
Yes.
So we'll, if we need a questionnaire class, I can do outside the class hours, which is like a sixth day, if that is fine for you.
Okay.
Or we can extend the class and maybe for a half an hour and do the session.
Yeah, whichever way everybody's comfortable and you're comfortable, I'm okay with anything.
Okay, that's good. Okay, Subbu, any questions from your side?
Currently, no, Sandeep. It's
Okay. Yeah, I think these are very easy topics, but we'll go into very deep. So I would suggest, even though I'm going to share these notes. Okay. Even though I'm going to share these notes, I would suggest you to write your own notes. The reason is, if you just follow my notes, probably I may not write everything, whatever I talk. It's your responsibility to write your own notes, I would suggest. And second thing is read every day. Maybe today is not the day what you want to read, but going forward, you may have to read a lot. The subject is very, very tough if you don't read, and it's very easy when you read every day. So I would suggest read every day, follow the classes, and if you have any questions, I am always there. Okay.
Okay. And when you say read, just read the notes, right? Or will you send any like PDF like
No, the notes, whatever I write on the notes is more than enough for you. You'll get at least 1,000 pages at the end of the course, by the end of the course.
Okay.
Just for my notes. Okay.
Okay.
Okay, that's how it is. Okay. Any other questions?
No.
Okay. Okay, then we'll catch up tomorrow at the same time.
Okay, thank you.
Okay, thanks.
Thank you, Sandeep. Bye.
Thanks, Subbu. Yeah, bye.